Hey physics. So I'm going to do a video for each one of these big ideas slides just to talk you through it, and because it's more fun sometimes to hear somebody talk through it than just to read it. So let's get into it. So the first unit we did in physics this semester was, we called it I forgot what we called it, but now we're calling it the basics of graphing because that's really what it is. How to determine relationships between variables by creating and reading graphs. So definition of a graph is a mathematical diagram that shows the relationship between one variable on the vertical axis and a second variable on the horizontal axis. So usually we have, we always have the independent variable on the, sorry, let me say that again. Okay, I wanted to check myself to make sure I was saying the right thing before I just plowed into it. We have the independent variable on the x-axis, and the independent variable is what scientists are deciding on how, it's the pace of the experiment. So it's and it is not going to be changed by the results. It's independent because regardless of what happens in the experiment, that is going to go in this regular kind of pattern. So for instance, on the independent axis here, we have Monday, Tuesday, Wednesday, Thursday, Friday. Those days are going to continue just like that. But then what we're interested in is the dependent variable, what's on the y-axis. And so what's cool about graphs is that they make this data visible. They make it so that we can really see a relationship between what's going on here. So the x-axis is kind of like what we sort of take for granted, and then the y-axis is what we're really interested in looking at. So if I'm wondering how many hot dogs are sold per day, then cool, Monday, Tuesday, Wednesday, Thursday, that's the part I don't have to think about, but it's important to know how it's set up. But what's interesting to me is, okay, so on Monday, we sell a lot less hot dogs than on Friday. So using the analysis of this graph, I can make a claim and evidence and reasoning about how many hot dogs are sold per day based on looking at this graph. So same thing here. So we're looking at time versus angle. Now you could imagine that this is going to be kind of like our cart on an incline lab, right? But looking at the different angles here. So the scientist is controlling the angle, 0, 20, 40, 60, and this is what we're interested in looking at. How fast does it go? And you can see this has an inverse relationship, and it is it looks like a deceleration, but really it's that the time is getting less and less as the angle gets bigger and bigger. Then this is over time, how tall is this plant getting? Interesting. Okay. So, recognizing a relationship from a graph. So, when you're looking at data and you want to determine, is the x-axis affecting the y-axis? Is my one part of data affecting the other one? Does it matter what day when I'm thinking about how many hot dogs are going to be sold? The day of the week is what I mean by that. So a strong relationship is going to be indicated by a clear line there, a clear pattern of data where I can definitely say here when I look at this data that as the angle gets steeper, the time that it takes that time traveled gets less and less. That's a strong relationship there. Angle definitely has an impact on time. A weak relationship is gonna it's just not gonna affect it very much. So there's definitely a pattern here. This thing is basically kind of hanging out at about 150 or 125 centimeters per second. But it doesn't look like the distance is really affecting that at all. So this is a weak relationship. And then no relationship at all is where the data are just scattered around. Last few digits of a phone number have nothing to do with the bands named that they right? So no relationship there. And this is one I do want to have you make sure you look at this one and review it, because I didn't do this one right on the Google form way back in the day. So strong relationship, a clear line. Weak relationship, there might be a line there, but there's not going to be a whole lot of change in that line based on changing independent variable, based on the changing x-axis. And then no relationship is going to just be super scattered. There's just the number of digits does not have an impact on the bands that they like. Okay, so now we can talk about a direct relationship, which is, I always like to do thumbs with this. Direct relationship is when one variable goes up, so does the other. That's a direct relationship, and that's going to look like a positive slope, a positively going line. An inverse relationship is going to be when one goes up, the other one goes down. So I'm sure you can think of a couple examples of that right away from our most recent unit. Like the more force you use, the more acceleration something's going to have, but the more mass something has, the less acceleration it's going to have. So direct, inverse. And an inverse relationship is going to look like a negative slope of a line, like what we saw here, inverse relationship. And then nonlinear complex relationships are going to be like where they're not making a super straight, clear line. It's something a little bit different there. So a direct relationship, like I said, it's a positive slope. So the more volume is there, the more mass is there. So think about like a pint of milk versus a gallon of milk. The more volume there is, the more mass is going to be there. Heavier it is. Straight lines, linear, slope up and to the right. So then we have inverse relationships, and an inverse relationship is a negative slope to a line. When one variable increases, the other variable decreases. Down and to the right. So mass and temperature, so the bigger something is, the more time it's going to take to heat it. So yeah, you can heat a little bit of mass to a high temperature pretty quickly, but as you get bigger, it's not going to heat as quickly, right? Inverse relationship there. So then we have a nonlinear complex relationship, and this is where like it's not just going up, it's not just going down, it's making some kind of other pattern that is interesting to us. So, like for instance, the distance from the ground of this ball when it's kicked. So then these are like looking at the angle. So it, like if you kick it at like a super shallow angle, it's not going to go very far. If you kick it at like 45 degrees, it's going to go super far. If you kick it at like a higher angle, then it might go higher, but it's as far as just like the distance it like is traveling, I guess distance would probably be more of like a horizontal distance. I don't know. But in any case, this arc, to me, this looks like whatever. So I had said this was a vertical distance that this ball travels. This is a horizontal distance that this ball is traveling. So if you're kicking it closer to like an angle that's pretty shallow to the ground, it's not going to go as far. If you're kicking it at a 45-degree angle, it's going to go as far as it possibly can go. But if you kick higher than that, then it's going to spend most of its energy going more upwards and less distance. That's what this graph is showing. So that's a nonlinear or complex relationship because it doesn't just the line doesn't just go up and it doesn't just go down. It does something interesting called a parabola. For example, this is one kind of complex relationship. Let's see. An MSA, you should be thinking about what are some examples, what are some real-life examples of parabolas? Like, what are some things that parabolas are useful for in real life? What did we study about that? Okay. So the independent variable is the one that scientists choose how to change. So again, this is that super regular thing that's kind of setting the pace of our experiment. And it doesn't matter what the results of the experiment are, that thing is going to go through at a regular pace. And it's always going to be on the x-axis, so we don't have to, so we're not thinking about it very much, right? We're looking at what is changing. So, yeah, so giving a certain amount of water. And it would really be like smallest, medium to biggest, right, on your graph. And then there's the dependent variable, which is what scientists are measuring, what is changed depending on the independent variable. So like how big is that plant when I give it certain amounts of water? How big does it get? Another example would be like, I don't know. You could think of some examples though, I'm sure. So that would be a good thing to do, like for practice for yourself, is think of some examples of like things that you could graph and which thing would be on the independent axis, the x-axis, and which thing would be on the dependent or y-axis. All right. So here's some practice. Mr. Krabs wants to make Bikini Bottoms a nicer place to live. He has created a new sauce that he thinks will reduce the production of body gas associated with eating Krabby Patties from the Krusty Krab. He recruits 100 customers with a history of gas problems. He has 50 of them, Group A, eat Krabby Patties with the new sauce. The other 50, Group B, eat Krabby Patties with sauce that looks just like the new sauce, but is really just a mixture of mayonnaise and food coloring. Both groups were told that they were getting the sauce that would reduce gas production. 2 hours after eating the Krabby Patties, 30 customers in Group A reported having fewer gas problems, and 8 customers in Group B reported having fewer gas problems. So, this is important to know about. So we talked about independent and dependent variables, but the other thing to make sure that you know about is what is a control. So a control is the thing that the scientists are keeping the same every time. Not the thing that they're moving at regular intervals, but the things that they're keeping the same between the different phases of the experiment. So for instance, Group A and Group B, what's the same between them? They're both eating Krabby Patties. They're both eating sauce that looks the same, and they're probably eating those things at the same time. They all have a history of gas problems. Those are all controls in this experiment, okay? And I'm going to tell you guys interesting facts about things. The herbs and spices that go into food, they actually are there, not just because they're tasty, but they actually help you digest. I just learned that recently, so that's kind of a cool thing. Slimatosis. SpongeBob notices that his pal Gary is suffering from slimatosis, which occurs when the shell develops a nasty slime and gives off a horrible odor. His friend Patrick tells him that rubbing seaweed on the shell is the perfect cure, while Sandy says that drinking Dr. Kelp will be a better cure. SpongeBob decides to test this cure by rubbing Gary with seaweed for 1 week and having him drink Dr. Kelp. After a week of treatment, the slime is gone and Gary's shell smells better. Okay, so the independent variable here is what treatment Gary receives, because that is up to the scientist to decide which treatment he's getting at what time. And the dependent variable is whether Gary still has slimatosis or not. That's the thing that we're interested in looking at. Does he respond to treatment? Let's see. Marshmallow muscles. Larry was told that a certain muscle cream was the newest best thing on the market and claims to double a person's muscle power when used as a part of a muscle building workout. Interested in this product, he buys the special muscle cream and recruits Patrick and SpongeBob to help him with an experiment. Larry develops a special marshmallow weightlifting program for Patrick and SpongeBob. He meets with them once every day for a period of 2 weeks and keeps track of their results. Before each session, Patrick's arms and back are lathered in the muscle cream, while SpongeBob's arms and back are lathered with the regular lotion. Which person is in the control group? Okay, so again, sorry, I had it's like slightly raining outside. Oh goodness. So yeah, which person is in the control group? So we want to know what happens if we don't change anything, right? So the control group is going to be if everything is totally normal, if he gets just a regular cream or whatever, then what's going to happen there? So SpongeBob is in the control group. And what is the independent variable? Which type of lotion? That's the thing that the scientists are deciding. And what's the dependent variable? How much power each person has. So again, what's the thing we're interested in? It's how much weight can they lift in that situation. Okay, last one here, and I'm going to go to a second video for this one. The dependent variable, what we always measure, always goes on the y-axis, and the independent variable, what we change, always goes on the x-axis. Yeah, scientists control that. This is what we're interested in looking at. Okay, so that's it for this video.